All right, dividing fractions. I think a lot of the grade 8s super hate number lines. Some of you have super hated them, and now you're in a love-hate relationship. Some of you hated them, now you love them. Did anyone like number lines the whole time? Okay, I'm that nerdy. I'm that guy. It says you've used grouping to divide a whole number by a fraction. So there was 4 divided by 2/3. And the way we did that, this is our quick review. So I have 4, 2, 1, and 3. How many times can I do 2/3 in there? Or if I divide it, cut it into 2/3 pieces. I'm going to pause the video and ask that people be more attentive and less disruptive during this video. So I've got thirds. There's 2/3. How many times are there 2/3? If I cut the 4 into 2/3 pieces, 1, 2, 3, 4, 5, 6. So if I cut those into 2/3, how many pieces are there going to be? Then we did the inverse of that. 2/3 divided into 4. Now I like to illustrate it like this. If I have a cake and I've got 2/3 left, and now I'm going to share it, I'm going to cut it into 4 pieces. I want to know, how big are each of those pieces? Well, if we do the symbolic method of that, we know that that would be 2/12 or 1/6. Or if I want to slow that down and see how I did that, that was 2/3 divided by 4. So we're going to flip it, flip, multiply, and then flip. And we get the same thing as before. So that's our quick review from last week. But now we're going to push forward and we're going to make it much more complicated. This is the 2.0 level up. As one of you said, no, there is no level up. Pish, tosh. Of course there is. You were 3.5, now you're 3.6, and we're going to make it more complicated. And this is usually where a student goes, but this is hard. And my response to this is hard? Good, I hate to be wasting your time. So, 2/3 divided by 1/4. If you recall in the last lesson, I said, imagine I've got a frog and I put him down on the tiles, and each time the frog jumps, 3/4 or 4/3, and how many jumps would he have in those tiles? Well, we're going to go right back to that, and I don't know if you can see from there, but I'm going to maybe zoom in. So I'm going to shake the camera. It's going to be really annoying how shaky it is, just so that you can see this. And here we have 2/3. And what's saying is, I have 2/3. Let's think of it like a cake again. I got 2/3 of a cake. But I'm going to divide it by quarters. That doesn't mean I'm going to cut it into quarters. That would be divided by 4. I'm going to see how many quarters are within it. And if I look, I've got 1/4, that's 3/12. I got 3/12, 6/12. Oh, and that's my 2/3 point. That's my 2/3 point. So now I'm going to draw that on the board. I'm going to bring it back so that you can see it. The production quality of this video is like insane. I should totally send it to Michael Bay, see if I can help shoot his next movie with him. So I've got 0, 1. Here is 2/3. And what we noticed was that we had 1/4, 2/4, and then it just jumped over. But what I noticed is that we had 3/12, that was 1/4. We had 6/12, and that was 2/4. This is equal to 8/12, but the next jump would have landed us at 9/12. So what we had is we had 1 whole jump, 2 whole jumps, and then 2 out of 3 of the final jump. So that was 2 whole jumps and 2 out of 3 of the final jump. Now I'm going to point out the correlation as per usual. The people who are very attentive right now, I notice, are the high scoring people in math. The people who are looking up at times usually get some reasonable marks. The people who have not looked up almost at all during this presentation are struggling greatly. So make sure that you understand the correlation of paying attention and getting those marks. Let's have eyes forward. Let's check our work. We're going to do it symbolically. Here we go. I got 8. I got 3. Do we have the same answer? Do we have the same answer? It doesn't look the same yet, but we have a proper mixed and an improper, and if we convert that to a proper mixed, yes, we have the same answer. Now I'm going to give you another example, because I don't expect you to get it yet. I told you myself right before shooting this video, I talked myself into a corner and I got a bit confused. So let's do another one. We've got 3/5 divided by 1/2. And here we have, I don't know how well you can see it, but I'm going to do it here and then I'm going to do it on the board. We've got 1/2 is right here. It's 5/10. Oops, sorry, I want 3/5. My bad. There's 3/5. And it says, how many 1/2s are there? Well, there's 1/2. So I get a complete jump in a little bit. One whole jump in a little bit. We got to figure out what that little bit is. But if I look at that little bit, I got 1, 2, 3, 4, 5/10, and then 1/10 later. That's my 3/5. So I'm just going to draw that right here. I got 0. I got 1. And I've got, there's my 5/10. That's my half point. And there's my 3/5, which is equal to 6/10. So there was 1, 2, 3, 4, 5. Oh, maybe I can put that a little bit better. One whole jump. The next jump would have gotten me all the way there, right? So we got to figure out, I know I've got 1 and a bit. I got to figure out what a bit is. Well, how many jumps? One whole jump. And how much of a jump is that? I want you to think quietly for that. How much of a jump is this? If this was one whole jump, 5/10, how much of a jump is that? What fraction of a jump is that? How many do you think you might know? You might know. Okay? It's 1/5 of a jump. It's 1/5. 1, 2, 3, 4, 5. Dunk. And 1. So that's 1 out of 5. 1/5 of a jump. One whole and 1/5 of a jump. Let's check. Did I get 1 and 1/5 of a jump? I did, because if I convert this into my mixed number, I have 1 and 1/5 of a jump. 1 and a bit. Let's look at another example, but that's done in a different way. So this is another method. Back in grade 7, you learned how to add your fractions. When you had to add fractions, the first thing you needed to do is you needed to have the denominator the same. If it wasn't the same, it just was not going to work out. I'm going to point out again the importance of paying attention during this lesson. I am losing my patience with that. It's obvious what you should be doing. It's also obvious what you're doing. So I'm just going to put that out there. Here we have 4/5. 4/5 divided by 1/10. Well, I'm going to back this up to grade 7. I'm going to do this. First thing I got to do, I need these to be same. Well, the first common multiple is 10. 1 times 10 is 10. 2 times 5 is 10. So I'm going to do this to top and bottom to get them the same. Do you agree that this is equal to that? Okay. So 8 plus 1 equals, 9. So 1/10 plus 8/10 equals 9/10. This is where you're probably getting a little confused because you're used to multiplying those fractions. But remember, when we add, we only do the top. So we've got 9/10. But we're not adding. We're going to divide. But when we're dividing these, we can also do the same thing by making these same once again. So I'm going to go times 2 times 2. 8/10 divided by 1/10. Now I'm going to pause the video. I'm going to see if we can take this down, and then I'll start the video and show you what we did. So now we have 8/10 divided by 1/10. So I'm going to go to the cake again. Let's say I have 8/10 of a cake. I want to know how many 1/10 pieces I can cut it into. So I've got 0, I got 1, I got 8/10 right here. How many 1/10 pieces can I fit in there? 1, 2, 3, 4, 5, 6, 7, 8 1/10 pieces. And you can see that a little here if you want to zoom in on your own with that. So from this number line, it's the same as 8. Like this. But I want to show you something. Isn't 8 and 8.1 the same thing? 8 divided by 1 is 8. 10 divided by 10 is 1. It's just like multiply. I divide the top, I divide the bottom. But it won't always work out the way you want. 5 divided by 10? Well, that wouldn't have worked, right? If I'd have gone 4 divided by 1, I'd have gone 4. 5 divided by 10. That didn't really work out very well. Can I have a decimal and a fraction? No. It is the same thing if that were allowed. By putting these as same on the bottom, I know for a fact that this is going to divide out on the bottom and give us a whole number on the bottom, so that we just have the 1 each time. So by making the bottoms the same, we know that it's always going to end in a 1, and whatever we divide will become a whole number. And if we want to use a decimal, we can. Because if I ended up with some crazy decimal, I could just take that 1 away and say that's like a whole number mixed into a decimal. So let's look at, do I have time in the video yet for one more example? Not really. So I'm going to end it here. I'm going to say, if you're a little confused, you can pause this at any time, you can back it up, take a look at the examples that are right in the textbook, and then come to me and say, Mr. Ewart, you broke my brain and your video sucked. Please come, help me out. I want to make this better. We'll make sure that you have this slam dunk. Your quiz is going to be pushed for Tuesday next week.